Hello class. In this video we'll be learning how to extract information from given statements, and we'll also be learning the 5 different triangle congruence criteria. Little vocab first. All of the basic rigid motions we've already learned are all examples of isometries. Those are also called congruence transformations. And basically, it's something you do to a figure, and all the distances are preserved. So in our proofs that we're going to get to, we have to justify every step with a definition, a property, or theorem, and we have to know when we can use those and why they're helpful. So, for example, we've already learned the definition of a right angle. So what picture can we draw for that definition, and what statement would that correspond to? So we would draw an angle that looks something like this, and we can say that our angle measures 90 degrees. So why don't you try something similar for these 5 examples, and we'll go through them together. So an angle bisector is going to cut that angle in half. So it's really a matter of taste what you say. You could either say that their measures are equal, or you could say that the angles are congruent. And same with the segment bisector. Segment bisector is going to cut that segment in half. So you can either say that the measures are equal, or that the segments are congruent. You have perpendicular lines. You can say that you have right angles, or we can jump to the conclusion that the measure of the angle is 90 degrees. Definition of midpoint, very similar to segment bisector, but now we're just using the term midpoint instead. Angles on a line, their measures sum to 180 degrees. So I can try the same thing for the last 3 we have here. So angles at a point, they sum to 360 degrees. The interior angles of a triangle, their measures sum to 180 degrees. And vertical angles are congruent. So let's see if we can apply what we've learned from that table here. So we have a given statement, and we want to write down something that's useful that comes from that statement. So think about example A here, and then we'll look at it together. So if we know that D is the midpoint, what can we say about each half here? You know that their measures are equal, and our reasoning will be definition of midpoint. And we can mark that down on here using little hash marks. You can put one on AD and one on CD. Okay, try letter B. So we can say, very similar to the previous one, that those 2 segments have the same measure. But now our reason is going to be definition of bisect. So be very careful with your vocabulary. If they give you bisect, you have to say definition of bisect. Okay, segment BD bisects angle ABC. So you can say that each of those angles has the same measure. Definition of bisect. And we can use these the same hash marks on the angles here just to show that they're congruent. Draw little arcs instead, though. And for D, those are perpendicular. So since they're perpendicular, we have a right angle. And depending on the problem, you can say that the other one is a right angle, angle CDB. And since we have a right angle, we can also say that it measures 90 degrees. Now, we've been allowed so far to just jump from step 1 down to this step. So we could have instead gone like this. But then our reasoning would be definition of perpendicular instead. So be careful with what you're stating. So the second step really isn't necessary, but it's correct, and that's where the third step would come from. But we've been allowed to just jump to 90 degrees. So you draw a little square in the corner. Okay, here are other useful properties that you've learned in algebra. So the first 4 are just the 4 basic operations. So if you add equals together, their sums are equal. If you subtract equals, their differences are equal. And if you multiply equals, their products are equal. And when you divide equals, their quotients are equal, provided that you're not dividing by 0. So be careful there. And with the multiplication postulate, although it's true that when you're multiplying by 0, everything will be 0, that's really not the best application of multiplication postulate because it'll turn everything to 0. So we really try to avoid using 0 to multiply both sides of an equation. Partition postulate. Right? When you partition something, you cut it into pieces. And when you put all the pieces together, that would be the same as the whole. So for example, in geometry, we could say that AB plus BC is AC. Right? Those are the two pieces. Put them together, you get the whole thing. Substitution we've been using. So instead of B, we're going to put 10 in there. And reflexive property. Right? Like reflect, like looking in the mirror. You look the same as yourself. I know it sounds silly, but in geometry, it's a very useful property. Anything is equal to itself. So that's going to be useful when we're doing proofs where triangles share an angle or a side. And we've already learned these four properties. These are all, they're all either theorems or postulate. One's a postulate here, but they're all very useful. So on the left-hand side, if we have parallel lines, then we know that these relationships are true. On the right-hand side, if we have those relationships, then the lines are parallel. So those are very useful. Okay, so let's look at the 5 triangle congruence criteria. So these are all different ways to show that triangles are congruent without using the rigid motions. Now, they can all be proved using basic rigid motions, but a lot of times it's a lot simpler to just use the congruence criteria that we're going to learn. So the first one is side angle side. And so if we have a pair of sides congruent, another pair of sides congruent, and the included angle, it's an important term, included angle. That's the angle that's in between the two pairs of congruent sides. Then you know that the triangles are congruent. So let's see, why is that true? Well, if we look at it with basic rigid motions, we can do a composition to get from this first picture to the last picture. So in the first one, we have a translation. We're translating the triangle on the right-hand side using vector A prime A. And now we've identified the two vertices together that have the congruent angles. Then if we rotate them, you know C and C double prime will coincide because we know that AC is equal to AC double prime. And finally, if you reflect it, if you reflect this triangle on the right over AC, segment AC, the triangles will coincide. So we can show side angle side is true by using those basic rigid motions. So now instead of using them, we can just say, okay, if we have these 3 criteria met, then the triangles are congruent. A lot easier than going through the basic rigid motions. So let's see if you can fill in the blanks here. We have different pictures. What transformations would you need to use in order to show that the triangles are congruent with basic rigid motions? So in the first one, we just have to reflect over segment AC. Then the second one, we have to rotate using angle CAC double prime, going clockwise, and we have to reflect over AC. Our second of the triangle congruence criteria is Angleside angle. So if you have 2 angles of triangles congruent, 2 pairs of angles congruent, and the included side, so the side in between them, then the triangles are congruent. And you could verify this one with a reflection. If you were to reflect C triple prime over AB, it would end up that coincides with C. So there's a bit more to the proof than that, but essentially it's a reflection. You also have side, side, side. When all 3 sides of triangles, all 3 pairs of sides are congruent between the 2 triangles, then they are congruent. And to do a proof of that with basic rigid motions, you end up proving it with side angle side. If you do a reflection here, you'll see that they coincide. And you could also do there's a longer way for the proof. You could show that you actually have side angle side because AB is congruent, distance AB is equal to distance AB prime. And you're going to show that these angles are congruent here, those included angles. And then BC equals B prime C. So you could actually prove this using side angle side. Our fourth one is angle angle side. So if you have two angles, two pairs of angles congruent, and then the corresponding sides are congruent, then the triangles are congruent. And this is an application of angle side angle. Let's see why. So if we have two pairs of angles congruent, what do we know about the third sides of the triangles? You know that they're also congruent. Nope, wrong order, sorry. So since the first two are equal in measure, the third ones must be the same, because you know they all add up to 180. So if the first two are the same, then the third one that gives you 180 must be the same as the one over here. And so this is really just angle side angle, because we said that these are the same. And so if we look over on the left-hand side here, the angles that touch this side, those pairs are congruent, and so you have angle side angle. Okay, so really, angle angle side is an extension of angle side angle. But depending on the problem, it might be easier to use this one than angle side angle. And finally, we have hypotenuse leg. So this says that if you have a right triangle and the hypotenuses are congruent and the legs are congruent, then the triangles are congruent. So why does this one work? Well, if we have two sides of a right triangle, how do we find the third side? You can use Pythagorean theorem. So you have a right angle. And so when you use Pythagorean theorem to find that third side, because we have two pairs of congruent sides, these ones are going to also be congruent. And so this is really an extension of, you could say side, side, side. You could also say side angle side because you have the right angle in the middle here. So either of those two is fine. So here's where we have to be careful. These are two examples of criteria that don't show that triangles are congruent. Side, side angle. If we look here, we have two triangles where we have a pair of angles congruent, and then the corresponding sides after it, if you're going like, what I mean by after, I mean if you're going like clockwise, so this side and then the next clockwise side, those are congruent to these ones. They're not necessarily congruent triangles. This third side could be like the short one over here or the long one on the right-hand side. So that does not prove triangles are congruent. And finally, angle, angle, angle. In this counterexample, we have two equilateral triangles, so all the angles are 60 degrees, but clearly the one on the right is bigger than the one on the left, so they're not congruent. So those two criteria do not show that triangles are congruent. So to review, here are the 5 different triangle congruence postulates and theorems. You have to know these. And we're going to look at different examples, and we have to identify which of the 5 we would use to show that they're congruent. So in this lesson, we learned about given statements and the different triangle congruence criteria. Thanks for watching this video.